Hello, welcome to the Bradley J. Show, and we're with Doug Arion today, and we're going to talk about the fact that it's increasingly more likely that you will be killed by space junk. Those factually, that's true. And there's a recent hi, Doug.
Yeah. Good morning. Yeah.
The recent incident is just another one of many where I believe somebody's house was hit by space junk, and so we're going to look into that and you know early on in various endeavors, like say Seattle. And Seattle had no sewage; they just would not worry about it, and this is kind of the equivalent of that.
Right.
You gotta, if you're gonna embark on this big, expansive thing, you gotta worry about your trash. It's like a town with no dump. You just no plan. Just
Yep.
dump your stuff where you want. Yeah, somebody gets hit by it, no problem. So first, tell us about this incident.
And we'll get into some of the statistics in a few minutes, but actually earlier this year, a piece of space debris came down and went through the roof of a house. I think it was in Connecticut, but don't hold me to that. I mean, literally just smashed right through their roof down to their house. So they're suing NASA over this because it was a piece of our stuff that came down. So interestingly, the agreements are essentially if you damage something in another country, you carry liability, but if you do it in your own country, you don't. It's a weird thing because of who owns what. So that's why this is a court case, because it's like, for crying out loud, a piece of your stuff just smashed into my house. You need to take care of this here. And there have been a number of bigger incidents long ago. So when Skylab came down, which was the first US space station back in the 70s, when it came down, it dropped debris all across Australia, which pissed off the Australians, not surprisingly. This is not the first time stuff has been falling down. I'm going to show you a couple of pictures in a few minutes. Yeah.
I'm curious, and you may not know the answer to this, but if it's found to be negligent, they knew that this is likely to happen, and they didn't do anything about it. Then that could be criminal negligence, couldn't it?
Well, I mean, this is part of the argument and why we have lawyers in courts is that on every reentry, there's a model that's run as to what altitude the thing's going to come in at, what angle, how fast, what should quote burn up. By the way, everybody should understand, burn up does not mean go away, right? Just when you have a wood fire, the fire goes out, the ash is still left. The wood doesn't just disappear, it becomes ash. The same thing here, there's ash up in the atmosphere as this stuff, quote, burns up. And most of the models that people have been using say, oh, this stuff is completely disintegrated before it reaches the ground, until something doesn't disintegrate and reaches the ground, right? And that's what happens here. So it's sort of like, a doctor operates on you and says, this is what I'm going to do and it should work, and then it doesn't work. That doesn't necessarily mean the guy did something wrong. Sometimes something doesn't work, and that's why these things have to get litigated. But as we're going to see, the probabilities of this stuff happening are getting higher and higher, and more stuff is coming down that, quote, wasn't supposed to. And so somebody needs to start rethinking this problem. It's a big problem.
Okay, talk to me about wasn't supposed to. What stuff falls down that wasn't supposed to, and how is it not supposed to? It's supposed to burn up into little ashes, or
right? Exactly.
I see.
Yeah, exactly. It was expected that it would all burn up and nothing would reach the ground. And speaking of which, by the way, there are cases where it's known that stuff will reach the ground. Satellites are big and heavy. Lighter parts are borne up, bigger piece is going to come down. So there's actually an area in the Pacific, which is the designated landing spot for all of this.
So, you mean the dump?
The dump, right. And again, it's interesting that we humans assume that if it's in the ocean, and this is the spot that is, if you put it on a map, farthest from any human habitation. So it's the safest place, right? And the assumption is that if it goes there, it's okay. The same way if you just have a dump down your street, well, okay, it's okay. It's in the dump, as if that's okay to ruin that area. I mean, if you happen to be the sea life in that area and this stuff comes down and kills you, you're not so happy about this, right? We just treat it because it's far from people That doesn't mean it's a good thing to do. So that's a whole other aspect of bringing stuff down.
How can you give me an idea of how fast the increase in junk or stuff going up is?
Yeah.
It's
Yeah, let me
exponentially huge, and that's an issue too.
That's a huge issue. So let me show you some pictures that should give you an idea about what's happening here. Okay, so the biggest collection of stuff going up in the last 5 years or so are these satellites to provide internet service. Okay, that's the largest number. There are satellites that go up that are weather satellites and communication satellites, and those go up, but they're relatively few and far between. These things are huge. So Starlink has already launched some 6,000 or 7,000 satellites. Their goal is to have, hold on to your civvies here, 42,000 satellites to provide satellite internet. Kuiper, which is being put up by Amazon, they have several thousand that they want to put up. OneWeb, which is a British company that wants to provide internet service, they have many thousand they want to put up. The Chinese want to put up their own system. The Indians want to put up their own system. So if you put it all together, there'll be an additional, are you ready for this, 100,000 satellites up there. So if you put up a lot of stuff, it comes down. So a Starlink satellite is designed to have a 5-year lifetime. That means every 5 years, you're going to deorbit that satellite. So if you have 42,000 satellites and they're each up for 5 years, that means each year 8,000 satellites are going to be brought down. 8,000. Also means you have to launch another 8,000 every year to replace them. So you run into, firstly, a big space junk problem, because every time you launch, you have stuff left over. And that stuff's flying around at 17,000 miles an hour. So that's one collection of issues. But the big issue is the stuff that comes back down. So here's some pictures. These are really current. This is recent stuff that was put up here. So there was this satellite that was brought down. There was a cargo freighter, meaning a spacecraft that was set up to bring materials to space stations. And that was re-entering. You can see what that looks like going through the atmosphere. A lot of people like watching them because they're very spectacular. It's much better than watching a meteor go over. But that ends up with debris on the ground. Now, the picture to the lower right, that is a piece of the International Space Station. That was intentionally dropped off. The units that go up there have a lifetime, and they didn't need it anymore, so they kicked it out. But that thing is, is bigger than a car door. So that's a big chunk of stuff coming down that smacks into things. Now, the more satellites you put up, the more stuff you've got, the more likely it is to come down. So believe it or not, SpaceX just got a contract. This is like last week or the week before, to be the company to bring down the International Space Station. So when it reaches the end of its life in a few years, it will be deorbited and it will be broken into pieces, and those pieces will then re-enter the atmosphere. And presumably they will be targeted to land in that South Pacific area, but the calculations are imperfect and you may have pieces floating there. So here's a real cool thing. Rolling Stone. Now there's a publication you wouldn't think would be applying to this. But right. Rolling Stone just put an article out about the stuff that's coming down out of space. And some of my colleagues are quoted in here. I sit on a major national and international panel that's dealing with these issues. We've been looking at this for the last 5 years, trying to figure out how to deal with all of the stuff that's going up and all the environmental damage. SpaceX launches their stuff from what's really a wildlife area in Texas, and they're being really significantly affected by all that. So that gives you some numbers and some pictures and gives you an idea. I mean, I don't think you'd want a car door landing on your house.
Oh, no.
Happy with that.
Okay, couple questions.
Yeah.
So these things are in an orbit, and they run out of what brings them down? they run out of gas, so that for some reason their speed deteriorates enough so that it's not enough to overcome their lateral movement can no longer overcome gravity, right?
Well, yeah. So basically, even though we think space is empty, there's actually a thin amount of atmosphere, right? Our atmosphere doesn't, we don't have air and then it stops. It slows down. So there is drag up there, and as a matter of fact, when spacecraft go up to the space station, they use their engines to speed it up a little bit and lift it so it doesn't keep falling down. And so slowly but surely, everything slows down and comes back. Now, of course, the higher it is, the less likely that is to happen, the longer it takes, but eventually things come down. So that's one collection of things that'll come down is some satellites are low enough, the drag will slow them down. Once they can't go fast enough, gravity takes over and down they come. The second group are things that are intentionally deorbited. So these Starlink satellites at the end of their lives will be intentionally, a little rocket will fire, slow it down it comes, and a new one goes up to replace it. And the same thing with the space station, right? It will be broken up into pieces. Each one will then have a little rocket on it that will slow it down and it'll come down. So there are both the intentional ones and the ones that come down by their way. You got a comment here, Russia blow up a satellite. Yes, they did blow up a satellite, one of their own defunct satellites. They used an anti-satellite weapon, blew that up, and that put up a tremendous amount of space junk. Because you take one piece that you can deal with, and now you have a zillion pieces to deal with.
God. Okay. Why? So they're mounted with a rocket. Why can't they're towards the end of the life a rocket fire that kicks them out further into space, out of gravity and out of drag? Does it take too much fuel?
Yeah, it takes a lot of fuel to do that. There are some satellites that are handled that way. But they're the satellites that are way out there. We call geosynchronous orbit, the ones that do your satellite TV. They're 22,000 miles up. And when they end their lives, they are pushed into an orbit that's out there where it's all been agreed. This is where you put the defunct satellites. And they'll stay there essentially forever.
Why? What is the reason that you can't put the internet satellites out there too?
So there are internet satellites out there. In fact, I have satellite internet. The problem is, or the disadvantage is, because they're 22,000 miles away. You have to be 22,000 miles up so that the orbit matches the speed of the Earth's turning, right? So that orbit takes 24 hours to go around, and so it stays in the same place. So your little antenna, you'll see this on people's houses, the little antenna points in the same direction all the time. So internet satellites, satellite TV, our big communication satellites, they're all at that height. The thing is, 22,000 miles is a long way. So the signal that goes back and forth gets pretty weak, right? Imagine taking your flashlight, your lights go out, your flashlight's good in your house, but if you're trying to light up your friend's house 3 blocks away, it doesn't do a very good job, right? So that's the problem here. The signal gets weak.
I see.
And so so the signal is slower, which is why I'm at the Mount Washington today talking to you, because my satellite internet at home isn't good enough. It's good enough for me to do email and to download some things, but it's not good enough to do video. So to make that work well, you want the satellites closer, but if they're closer, they go faster, right? They're not overhead very long, and then you need more satellites. So that's the competition. So to have fast internet from satellites, you need them close, and if you have them close, you need a lot of them, and a lot of them becomes 40,000.
Folks, we're with Doug Arion, who's with Mountains of Stars. We'll talk about that at the end, and the American Astronomical Society, talking about space junk and the increasing risk of it. Okay. Are certain areas of the Earth more vulnerable because space junk tends to collect there, either because that's where the satellites lived, or because of some sort of rotation of the Earth, and how belts form with rocks? Do belts of space trash form, and that puts whatever's under the belt at higher risk?
So satellites are launched into a number of different orbits, okay, depending on what their job is. So when they're launched, from the US, we launch a satellite from Florida. That doesn't go straight to the east. It's launched towards the northeast, so that as the Earth turns under it, that satellite can look at parts of the Earth. Starlink satellites have to go into all sorts of orbits so that every place on the Earth can see them. So that covers the entire planet. Other satellites, that angle is called the inclination, that they're launched at defines what latitudes they'll cover. So Russian satellites are steeper because they're farther north than we are. Ours are not quite as steep, but so there's a band. So if you're at the North Pole or the South Pole, relatively few satellites go over you. In fact, northern Canada, southern South America, fewer satellites go over you. But between 50 degrees north and south, which basically gets you everything from Australia up to Montreal-ish, that band, there's a gazillion things over you.
Do these pieces of space junk interfere with keeping an eye out for asteroids, which could destroy the Earth?
Potentially. So these satellites all reflect some sunlight, right? They're up there, you can see them. So early in the night, late in the night, they reflect sunlight, and that impacts our big telescopes because they're looking up and you get these bright things going through. And so some of the telescopes, there are several around the world, one new one being built, are designed to look for the rock that'll hit us. And this collection of satellites is going to impact the ability of those telescopes to see stuff. It's going to mean that more images have to be taken, and that means you can't cover the sky as efficiently. So it increases the risk of the fact that we're going to miss something. So you're driving down a road, and it just happens to be the time as you're going down the road that another car is coming towards you, and their headlights sort of blind you, and that's when you hit the moose, right?
Right.
You wouldn't have hit the moose with your headlights, but at this time, it's just the wrong timing, right? At the time that you come to the moose or the deer, that's when you get blinded. So we don't want that to happen. So that's one of the consequences of this. I'm not going to say it's a less important. There are so many consequences of this stuff, both the environmental damage from launching all this stuff, the space debris problem, the chances of space debris hitting a satellite you want to keep, like a weather satellite, debris coming down. We can already measure pollution in the air from the reentry of satellites. We can measure the dust that's coming into the upper atmosphere. So these are all big problems. So yeah, there's a whole collection of things that this causes.
Johnny asks, what kind of threat does space junk have on moon launch or something like that?
So as the satellites go up, once you have a lot of them, the timing for when you can launch, because you're trying to cross a freeway, right? You have to launch when this stuff isn't around. So the more stuff that's up there, the narrower are those windows, and there is always a risk. I mean, periodically, matter of fact, a week or so ago, was it on Thursday? Everybody in the space station had to go to their safe quarters because there was a chance of a piece of debris hitting it. And that could happen to any spacecraft. On the other hand, there are plans to launch all sorts of things to go around the moon. So starting to create the same problem we have around the Earth, to create that problem around the moon.
What do they want to put stuff around the moon for?
So one of the ways that you navigate on the Earth is GPS, right? GPS tells you where to go. Mm-hmm. The idea is to put up the equivalent of a GPS around the moon so that robotic spacecraft can go and mine things on the moon and do things on the moon and know where they are. So now you're going to talk about putting a whole collection of spacecraft to do GPS, the equivalent of GPS, and another one to do communications. So that, remember, the far side of the moon we can't ever see. So you need relay satellites that you can talk to your rover on the backside that's mining your stuff. So you have to have a whole bunch of them to relay that stuff around.
How viable is mining on the moon? The moon is pretty close, 250,000 miles approximately, right? What does it take? A couple days, 2-3 days to get there. Is mining a viable thing?
It's a matter of money, right? I mean, the technology to put a rocket up there that comes back, it's a matter of money. You have to build a whole bunch of big rockets. If you're mining, it's heavy stuff. Heavy stuff takes a lot to lift. It takes less to lift it off the moon, of course, right? It less gravity. But you're going to put in 6 times as much stuff. So you need a big rocket to be able to send stuff back. And
So-
then you have to re-enter it here and get it back down to the ground. One of the things that's interesting about the moon, and there are spacecraft going up now to look for places where there's ice in craters that never see sun, because ice has hydrogen and oxygen, and then with power, electrical power, you can split that and make rocket fuel. Because you're going to have to make fuel there. There's no way to carry up enough fuel to come back, because fuel is heavy.
Yeah, it doesn't seem like at this time it's worth it unless there's some super valuable, ultra rare metal kind of thing that you need.
Exactly.
Okay. Now, is regulation pointless? Is it? Is there any regulation that can take place, or does the technological ego and march forward supersede any sort of regulation?
We're working on it. There's a parallel group to the one I'm on. There are people who serve on both of them. It's called, and it's through the International Astronomical Union, that is bringing this to the UN. So they're working with, there's a committee on the UN called COPUOS, which is the Committee on the Peaceful Uses of Outer Space. And that committee is the place to go to try to put some treaties together to regulate this stuff. Because when you don't have regulations, you end up with the Wild West, right? When we didn't have any regulations, people just went out west and homesteaded and built stuff and did whatever.
And claimed that the land was theirs, by the way.
And claimed that the land was there. So one thing we do have treaties that say you cannot own the moon, for example. A country can't own the moon. But you got to expect that if a mining company went up there, you can, I don't know what your retirement plan looks like, but if you had a bunch of money, you could pay somebody to build a rocket for you and you could launch it and go to the moon. Perfectly okay. The US can't claim they then own it, but if you start mining in an area, presumably you're going to want other things not going into your mining area.
Right.
And then you're going to run into those, basically the same problems of what does it mean to control those spaces, right?
Right. Just like the gold rush. You had to stake your claim. I got to stake my claim.
Right.
Wow.
Exactly.
I had another question, and I can't remember what it was. But, oh, yes, here it is. Did we finish on regulation? Because I have the next question.
Yeah.
Okay.
I think so.
So why haven't, it seems to me, if I were in charge of the military, I would want space lasers from satellites. That doesn't seem like a very far-fetched thing. You really can be accurate with them, and lasers are a thing. Why? Maybe not lasers, maybe some rockets or whatever. I don't know. But why aren't there satellite or space-based weapons?
There are satellite and space-based weapons. There are treaties on doing some of those things. But of course, treaties are only as good as the people who follow them, right? I mean, Just think about any sporting event. In every hockey game, there are penalties. I mean, the rules say you shouldn't slash another player on the ice, and you shouldn't hold somebody, and you shouldn't trip somebody, and yet that happens, and something happens, right? The same thing with treaties. You say a treaty, well, we're going to agree not to do something or to do something, and that's only good until somebody breaks the treaty. We have rules that say you shouldn't invade another country. Well, let's look what's happening around the world, right? So so. For example, your listener before pointed out, that the Russians destroyed one of their own satellites with an anti-satellite weapon. All the major countries have anti-satellite weapons. We have them. The Chinese have them. The Russians have them. Other countries have built rockets that can go and destroy satellites. Putin, not long ago, said he might just want to put a nuke up in space, even though we have a treaty that says we're not supposed to do that. What's going to keep him from doing it and going, well, sorry, I don't like that treaty anymore.
Right.
And as far as lasers, microwave weapons, kinetic kill vehicles, all of these, those were very heavily studied in the 1980s. I was part of that work under what was called Star Wars, if you remember the Star Wars program under Reagan. And there the goal was, could these weapons be built and actually knock out other spacecraft? Of course, that was the technology of 40 years ago. Technologies have improved in 40 years, but those are definitely, they've been researched. I'll tell you that.
How come we don't have land-based laser weapons? If laser weapons work, I mean, it'd be so much cheaper than an ATACMS missile, $1 million a crack or whatever it is. You know, all you need is a lot of power, and electricity is relatively cheap. You could burn a hole in a tank.
Well,
Why don't we have those weapons? Is it not really work very well?
the issue is there's this stuff in the way called air.
Yeah.
If you try to propagate a lot of energy through air, that air breaks down. I mean, you're heating the air, the atoms split apart, and then that starts to absorb the energy of your beam and scatter it. So you can't just put more and more power through air. Now, space to space, right? Satellite to satellite works fine, right? No air in the way. You know, it's just a matter, as you say, it's a matter of how much electricity can you put together. You need a lot of electricity, big solar arrays, big batteries, whatever. And then you could do that. But from space to ground or ground to space, that becomes an issue. So for example, another space problem, give you another collection of these. There are groups that want to put big solar arrays in space, collect sunlight, and then beam that power down to the ground. Okay, well, you can collect the sunlight up there, but if you have enough microwave power to send that down to the ground, you're going to destroy stuff on the ground. And it's microwaves, right? You know, lasers have the same problem. There are now satellites that they're talking about, and there's some tests up there that are what called DTC, direct to cell. So your cell phone, instead of talking to a tower, will talk to a satellite. So that has the advantage you don't need towers, right? It would work, you know, you're up in the Maine woods where there are no towers, your cell phone would work. But those satellites are really big. And now you're going to have big things flying in space. And we go back to the start of our conversation half an hour ago and now add a whole bunch of big satellites up there. So they're talking about doing those things. And then there are companies that want to put satellites up for advertising. So you and I are of a vintage that you may remember airplanes doing the messages in the sky thing. That's kind of gone out of style, skywriting.
Yes.
But imagine skywriting in space. So you're there at night and all of a sudden floating over you is the Eat It Joe's message.
Okay, that's pretty horrific.
Yeah, but these things are technologically possible, and there are groups that are trying to do this. And you know, you talk about kind of, you know, killing the stars for you. Imagine a big bright thing flashing over, you know, Eat It Joe's.
Good God.
Crazy, isn't it?
Doug is particularly well. It's fitting that Doug talks about weapons because, and I always find this interesting. Doug spent a lot of time working on nuclear survivability, not so much of people, but of our weapon systems, right?
Right, exactly.
Which is, I find super interesting. And of course, I thought about you so much when I was watching Oppenheimer, and we spoke about it a little bit, but you loved that film, and so did I. And there's a lot going on there, a lot more than just science. Let's see what Johnny says. All that money in satellites, you think Elon or NASA would be cleaning it up? Yeah, that's expensive, and nobody's going to spend money if they don't have to.
Right.
So
another great movie.
Go ahead.
That you may want to look into that relates to this. In fact, I just watched it on Amazon Prime yesterday. It's one called Radioactive. It's actually the history of Marie Curie.
Oh, wow.
And the discovery of radioactivity. It's a fantastic movie, so I highly recommend Radioactive.
Where did you find that?
On Amazon Prime.
Amazon Prime. Good.
I'm sure it's available through Netflix or other things too, but I saw it on Amazon Prime. But Radioactive, brilliantly acted movie. Rosamund Pike plays Marie Curie.
So as we wrap it up, is there any resolution to the space junk problem in sight, or not really?
It's a challenge. It's either going to take enough people in enough countries for the UN to get a treaty together so that, you know, this stuff gets regulated. I think it's going to be tough to do that now that commercial ventures are capable of doing this. You know, when space was strictly done by governments, you know, things were on a smaller scale and It was easier to control things. But you know, when anybody can do anything, it gets complicated.
Plus, if you can't even motivate people to deal with climate change when when people are exploding down south and your lawn's burning up and the wildlife's dying and your plants are dying because they're getting cooked, if you can't motivate people to change something that's so finite, it's going to be tough to get them to change anything so abstract, is what I'm going to say.
Agree.
Before we go, remind folks about Mountains of Stars.
So the program that I've been running for the last 13 years, Mountains of Stars, our motto is environmental awareness from a cosmic perspective. I think if we understand where we fit into the universe and where we came from and how everything is interlinked, we treat things differently. And that's why I'm involved in these issues of things like space debris and environmental issues and impacts on the ground and effects on water, because I have a background in astronomy and astrophysics. I understand that this is a little blue rock floating around in space and we need to deal with it. So our website, mountainsofstars.org, has a lot of tremendous resources. We've posted up many of the podcasts Bradley and I have done over the years. We've been talking for a long time. This is really great that we can do this and reach people, because the more people we reach, the more folks will wake up and go, no, wait a minute, I'm going to change what I'm doing, or I'm going to call my congressman and say, we need to work on these problems. So I hope we can have an impact. That's what I've been working on for a long time.
Okay, Doug, such a pleasure. It's great to speak with you this way. It's great to speak with you in person, but that involves a long drive. But I don't mind driving up, because you used to drive down to do the show, and I always appreciated that. So this is a great, easy fix to hang out with you, and it's always fun. Thank you very much, and let me know when you come up with another awesome topic, and we'll get it right on.
Sounds great. Looking forward to it.
Everyone, do me a favor. If you see this, share it and rate it and like it and subscribe. Do it. You know what to do.
Yeah.
Take care, Doug.
Thanks, Bradley.
Okay, don't go away. We'll just be